Welcome to our new lesson, and today we're going to learn how to determine the maximum or minimum values and the range of quadratic functions by using the completing the square method that we learned in the previous lectures. Now this is useful when you try to understand the behavior of quadratics, and you should already be familiar with the general form of a quadratic equation. Actually, before that, let me just start the lesson by putting down the title. So we're going to be using the vertex form. All right, so we're going to be using the vertex form. I'm going to write this in green, right? And as I said, we want to use the vertex form to understand the behavior of quadratic functions. All right. Now, first off, let me just recap a few things and we'll move from there. So the first thing I want to recap is that you know what the general form of a quadratic equation is. So this is the general form. General form of a quadratic equation. So f of x is equal to ax squared plus bx plus c. And we also know what the vertex form or the completed square form that you're required to learn. So vertex form is f of x equal to a into x plus h close bracket squared plus k. All right, so you know the vertex form, you know the quadratic equation, and what we're going to do is we're going to use this vertex form here to obtain values for the maximum and minimum. So we're going to be able to determine whether the graph that we have, whether the quadratic function that we have is a maximum function or a minimum function. We're going to be able to find that maximum value or minimum value on the quadratic curve itself. You'll also be able to identify the line of symmetry, and finally you'd be able to determine the range of values that that function has. All right. Now it's going to be a one-sided range. Either it's going to be greater than a value or less than a value. And when I draw the functions for the quadratic equation, you'll understand what I mean by that. Now let's first draw a general form quadratic equation. All right. I'm going to draw the function. So the function can either look something like this, or it could look something like this. All right. Now, when the parabola opens upwards, that happens, as you know, in the instance where a is greater than 0. In the instance where a is greater than 0, the parabola opens upwards, and the vertex represents a minimum point. Why does it represent a minimum point? Because if this here is your y-axis, and this here is your x-axis, what we're saying is the minimum point is actually the lowest point on the y-axis, right? The lowest point on the y-axis. Everything else is going to be above that, right? Every other value for the y-axis is going to be above that. So right away you get an idea of the range, right? So the domain values come from here, as you already know from math, and the range values comes from here, right? So the range of values that we have for a function where a is greater than 0 is going to start from this vertex point down here and go upwards. Similarly, we're going to have the same thing happening when the quadratic is shaped like this. So if this here is your quadratic, this here is your function or your y-axis, this here is your x-axis, you're going to have a maximum point over here. So this is your max, and this here is, let me just label it properly, maximum point. And then we have here, which is your minimum point, right? And then everything starting from this point go downwards is the range of values that are valid for this function. Again, this happens, as you already know, when a is less than 0. So when a is less than 0, you get maximum points. And when a is greater than 0, you get minimum points. All right? So just to make a note of that, I would just simply write a little note here for you. Hold on. Let me just put this here. So it's if a is greater than 0, not 0, then the parabola opens upwards, and the vertex represents the minimum point. All right, and then if a is less than 0, then the parabola opens downwards, and the vertex represents the maximum point. All right, so that is how it's going to work. Now you can identify the max and the min point just by simply knowing the value of a, and remember the value of a is this. All right, so that value will tell you whether or not you're going to have a maximum point or a minimum point, and the range of values that you're going to have is going to be, for your maximum point it's going to be less than that maximum point, and for your minimum point it's going to be greater than that minimum point. All right, now we are also able to obtain from this general form here the vertex point, which is this point here and which is this point here. So both of them, as I already said, both of them are vertices, vertex, right? So this is a vertex point and that is a vertex point. How do we get that vertex point? That vertex point comes from the vertex form, and we're saying that that vertex point, and I'll write this in a new note, so the vertex point is negative h k. So we take whatever value k is, we find the negative of that, and then put in the k value, and that here is the point. So this point up here, and I'll put this in orange, so this point up here is negative hk, and again, this point down here is going to be negative hk. All right, so that's the vertex form used to determine your maximum point or minimum point and your vertex point. All right, now let's apply the knowledge of finding your vertex form to find the maximum, minimum, and the range of a quadratic equation. And since you already have the information, let's do some examples. All right, example 1. Let's try and solve this one. So I'm going to write the steps that I'm doing, and then you're going to be able to follow this along whenever you have to solve a problem like this. All right, so the first step, and I'm going to write this in a different color, let me just use blue. All right, so the first step, once you have this, is to complete the square. Complete the square. All right, that's the first thing we want to do. We want to complete the square. So we're going to start with this, and we're going to say f of x is equal to x squared plus 6x plus 5. Now we're completing the square, and I'm going to take my time again and solve this so that you'll see exactly what I'm doing is the same things that we did before. So f of x would be equal to, open bracket, x squared plus 6x plus, open bracket, 3 squared minus, open bracket, 3 squared, close bracket, plus, well, I don't need to have a bracket because a is 1, so I have 5 there. So this here is my perfect square. So I say f of x would be equal to x plus 3 squared, and then this here is negative 9. Negative 9 plus 5 is negative 4. All right, so that's the first step finished. The next step is, once we've completed the square, we want to identify the vertex. So I'm just going to write that there. The second step is to identify the vertex. So solution to that. So the vertex is at negative hk, which is equal to negative 4. Sorry. Let me just make sure of that. So we have here a positive 3, we have here negative 4. So we're going to take the negative of the h value. So we're going to take the negative of the positive 3, and then we're going to take the k value, which is just simply 4. So negative 1 by 3 is going to give me negative 3, and this k value is negative 4. Hold on, negative 4. Right, so the k value is negative 4, so I put that value in there, and that's it. Right, so we identify the vertex. And then the last part, which is part 3, we want to, well, step 3, we want to determine the minimum value and range. All right, so we want to determine the minimum value and the range for the quadratic that we have. So I'm just going to write this here, and I'm going to say, since a is greater than 0, and in this case a was equal to 1, right, the curve looks like, and it looks like this, right? Let's say our function is somewhere here, f of x is there. Let's say this is x, so this is x, this is f of x, and here is going to be point negative 3, negative 4. All right, I don't have to do all of this. I can just simply state that it's a maximum, sorry, it's a minimum curve, and just simply work from there. But I'm just doing all of this so you can see what's happening. Right, so it looks like this. I don't know what these values are, and we're going to do that later on in the lessons. But right now, we're just concerned with this point here. So it's here, right? It's here, and we know that this here is going to be negative 3, and this here is going to be negative 4. And that, your maths will teach you that already. All right. Now, we know what the parabola looks like. We know what the quadratic equation looks like. So now we can say something like the minimum value is negative 4 at x equal negative 3. So again, notice what we're doing. We're identifying the minimum value, which is down here. I'm going to put that in a highlighted green. This is a minimum point. Right? This is a minimum point. This is the minimum x value. sorry, not x value, y value, or I should say function value, right? That's the minimum function value. That -4 there is the minimum function value. This tree here is just any tree. So it's telling me that this minimum function value occurs at x equal -3. All right. And we're also required to state the range. So we already know that the minimum value is -4 at x equal to 3, right? Or we can say the function is -4. The minimum value of the function is -4. In fact, you know what? The minimum value, and I'll just put here in a different color. Let me put it in red. Minimum value of f of x is -4 at x equal to -3, right? So that's the minimum value. And then the range is as follows. It is the set of y that is a member of, is the set of all y that are members of the set of real numbers such that y is greater than equal to -4. So that is telling me that any y value greater than or equal to -4 belongs to the range of values that exists on this quadratic, right? That's the range of values that exists on this quadratic function. Let's go on to another one, and I'm not going to explain so much anymore. I'm just going to give a quick solution so that you can get the answers quicker. Let me just put this in yellow, and I'll put this as example number 2. I know I was using that color before, but I'm just going to use yellow now. So I'm going to say given f of x is equal to -2x squared plus 4x plus 1, we're required to find the maximum value and determine the range. All right. So what I'm going to do now is I'm going to write out the solution without putting in the steps that I wrote out here. Right. So all these blue steps that I wrote out here, I'm just going to write the solution without the steps so you can see what my solution would look like. I'll put that solution in this color so that you can see, you will distinguish it. Right. So given that f of x is equal to -2x squared plus 4x plus 1, and then I can just simply factor out here. I will get -2 into x squared minus 2x close bracket plus 1. Then I can do my calculations mentally, right? I can work around with this plus and minus, and I can get it mentally done. And I can see here that -2 divided by 2 is going to give me -1. It's going to be -1 squared plusing and -1 squared subtracting. So I work that out in my head, and I will be able to get the answer of -2, which is already out in front. I'm going to have the x minus 1, which is already known, put the square, and then work out the outside part in my head, which will give me 3. So that there is the completed square form once I'm finished. Now, this means I can just simply go straight to the vertex. So the vertex, then the vertex is -hk, and that -hk is, what's it? That's negative of -1. So I'm just going to put here negative of -1 and then 3. And then you can see right away that this here is just going to give me, you know what, I should put this in white and then put the other piece. So I'm going to put this in white. So I'm just putting it in white because this is what's going on in my head, right? This is what's going on in my head. So I'm just going to put here 1, 3. And that's the answer for the vertex. And then once I get the vertex, then the next thing I have to do is just state everything that I need to state. So I'm going to say that since a is less than 0, and in this case a is equal to -2, then the function f of x, then f of x, I should say, is a maximum curve, right? And then now that I identified some maximum curve with maximum value 3 at x equal 1. The range is all the y values that are members of the set of real numbers such that y is less than equal to -3. Let me just make sure that value. Sorry, not -3, less than equal to 3, right? So it's a set of all real numbers, sorry, it's a set of y that belongs to the real numbers such that y is less than 3, all right? So we're going to have a curve, and I'm just going to draw a quick curve here. So we're going to have a curve that looks like this. the point on the curve up here is going to be 1, 3, and the range of values is going to be anything from this point downwards. Notice that's why we call it a maximum value. So it's the maximum it's going to reach. It's going to be everything below that afterwards. So this here is the range, and this here is my vertex, and that's it. All right. Let me do one last one. We're going to see a final solution on this, and then I'm going to give you some problems to solve. All right, so let's solve number 3 now. So the solution, we're going to say given f of x equal to 3x squared minus 12x plus 7. Then we're going to say the vertex form is, and I can write this here, f of x equal to 3 into x squared minus 4x plus 7, and then work that out, and I would get half of that is -2. So that means that here would be 3 into x minus 2 close bracket squared, and then that will be 3 by -2 squared, and then add 7, which should be -12 plus 7, which is 5, right? And then we get that. So the vertex point is, well, negative h key. So I'm just going to say, and again, let me do this in white so you can see what I'm thinking. So I'm saying negative h key, right? And then I simplify and expand that out, and I'll get something like 2, -5, right? So that's my vertex point. Okay, and then I just simply have to write the statements at the end. So since a is greater than 0, and I think in this case is a 3, so greater than 0, a is equal to 3, then the parabola is a minimum, right? So as long as value positive, it's minimum, okay? And we can say the minimum value is -5 at x equal to 2. And then we can talk about the last part, which is the range, and say that the range of f of x is everything. So since it's a minimum, that means everything above it belongs to the range. So minimums tend to look like this. So that means with this here is my vertex point. So everything above it is the range. So the range of the function is the set of y that are members of the set of real numbers such that y is greater than -5. All right, so that's the answer for that one. All right, so for every single one of the problems, what you're going to do is you're going to find the vertex, you're going to determine whether it's a maximum or minimum vertex point, and you're also going to find the maximum or minimum value and state the range. So I'm just going to give you 3 actually. So the first one is f of x equal to x squared minus 4x plus 1. Then we have next one as f of x equal to 2x squared plus 8x plus 5. And the third one, you're going to get f of x equal to -x squared plus 2x plus 3. And that's it. I'll see you next time. If it is that you have any questions or comments, make sure and leave it. If it is that you have any issues that you want to contact me about, you can either use the comments or you can use the Google Classroom that is relevant to this course. And you'll find the Google Classroom link in the description. And that's it. That's the last topic, well, the last lesson for this week. And I will see you next week on Monday when we start again.